Hello, everybody, and a warm welcome to this today's webinar, which is co-held by Altas IT, SFC Energy, and Flowline. So I'm happy to see that we have so many participants today. Today's webinar will be about sewer and surface water flow measurement in remote areas, and we have two speakers today. First of all, is going to start Mark Davies. A little bit about Mark. He has been working in the flow metering industry for over 26 years, so he's got a lot of experience in this field. And his background is in manufacturing and aerospace. So today he mostly specializes in sewer and effluent flow metering, in particular real-time monitoring and control of hydropower and sewer networks. And our second speaker will be Knut Kalbach from Germany. He is a technical sales manager at SFC Energy, a German company. And he's responsible for the business development in the Eastern European markets. But without further ado, I'm going to hand the floor to Mark.
Okay, hopefully everyone can hear me. So I'm Mark Davis, MD of Flowline Estonia. And as the title says, we're going to talk about real-time off-grid sewer and surface water flow metering. So I'm going to go fairly quickly through the presentation, but this will be available to download later. It will also have Estonian translation as well on the download. So what are we going to talk about? Well, a little bit about the company. Then we'll talk about different types of flow meters, which will lead on to the meters that can be used for surface water and sewer flow monitoring. And that nicely leads into real-time sewer monitoring with remote monitoring. And then off-grid and remote power will be covered by Knut. And then it will come back to me where I'll give you some real application examples of real-time sewer monitoring systems. And I believe we are finishing with a Q&A. So very briefly, who are Flowline? We're located in Tallinn, but we cover Estonia, Latvia, and Finland. We are the local agents or representatives for various manufacturers based in Germany, France, and Belgium. We've been working with these manufacturers for, in some cases, over 30 years, from Flowline in the UK and also Flowline in Estonia. We've been supplying Estonia since 2012, but I started Flowline Estonia in 2019. And as Jürgen said, I've been involved in the flow metering industry for a long time. And I now basically specialize in difficult applications, which usually involves effluent and sewer monitoring, a lot of retrospective metering. It's very common for really, I would say about 90% of my metering applications are adding flow meters to a network or a system or a process where there wasn't a flow meter before. And that's a very common application for us. And I'm located in Tallinn. So what is a flow meter? If you're involved in the water industry in any way or mean, you're going to know, you would have come across flow meters. But a flow meter measures flow. Liquids, gases, air or steam. We can either measure the rate, or in other words, the speed of a flow, but we can also measure totals. So of course, if in your house or apartment, you will have at least one flow meter, usually two. The first one you have is for water, which basically is a mechanical totalizing meter. The second you will have will be for possibly gas, again, usually mechanical, but more electronic gas meters are coming along now. We can basically measure any type of fluid, clean or dirty, corrosive, acidic, pretty much anything can be measured with the correct type of flow meter. Flow meters are often mechanical. Most of the time these days, they're powered meters. We also offer what we call non-invasive meters. That means they will clamp on the outside of a pipe, or invasive meters that require a pipe to be broken into. You can also have meters for fixed or portable applications, so for flow surveys, etc. So let's look at some examples of ultrasonic flow meters. These are clamp-on, so they do not interfere with the flow. You can install and remove them without shutting the flow down, and they're suitable for clean water, raw sewage, effluent, even flows with heavily laden silt is not a problem, again, with the correct type of meter. Top picture, very nice clean water supply pipe. The lower picture shows quite an old corroded cast iron pipe. Again, it's not a problem as long as the rust is removed where we put the probes. And you can see here we have a probe on the left side of the pipe and a probe on the right, but effectively look at each other at about a 45-degree angle to measure the flow. Slightly different, 6.5 meter diameter pipes. These are on a low head hydropower scheme. And you can see there, to give you an idea on scale, one of the probes, the other is on the other side of the pipe, the opposite side. Those probes, dimension-wise, they're about 2 centimeters square. So that gives you an idea of the size. The picture on the bottom, you can see, is a buried solid concrete water pipe. This pipe is full. It's used for supplying water to a very large city. And we are measuring that flow without breaking into the pipe using clamp-on ultrasonic probes. After the probes were installed, the entire pipe was buried again. Gas flow meters, relevant for water treatment. If you have biogas generation, which you use for generating power, you will want to measure that, and you can use different types of flow meters for that. The one on the right is an example of biogas going to a containerized diesel generator. It's quite a common application. This flow is slow, and it's also what we call dirty. It's corrosive. It may be wet as well. But cleaner airflow examples, this is blower air to go to aeration basins for raw sewage treatment. Again, small insertion meters. These are installed without the flows being shut down. And finally, for our full pipe meters, we have a very common flow meter used throughout the world in the water industry for clean and dirty liquids, an electromagnetic or mag meter. It breaks into the pipe, but once they're installed, they are incredibly reliable, very accurate. They can be direct buried if you want, but essentially this is really the gold standard of metering for clean and dirty flows. Sewer and surface flow meters. So the main challenge here is, of course, you have a part full pipe or a channel. But if you're going to use a meter for real-time control, we'll start to look at some of the requirements. It must have no moving parts. You can't have anything in the flow. It will get cruddy, and we'll have a look at some pictures in a minute to look at that. It has to be robust. IP68 means it can be submerged without being destroyed. That's very important with a sewer network, obviously, is you get surcharging with high flow events. Ideally, it should be low power, so it can be powered by solar power or what Knut's going to be talking about. Very wide flow range. I'll give you some examples of the type of flow ranges that we're looking at using the same piece of equipment. And of course, the outputs should be compatible with your telemetry. So ideally Modbus, Profibus, web-enabled as well, which will also give you real-time data and also give you diagnostic information, which is very important. So how do we measure flow in a part full pipe? We need two pieces of data: the speed, the velocity of the flow, and the wetted area. The wetted area you get from the size and shape of the pipe and how full it is. We measure that using a look-down ultrasonic level sensor. We measure the speed using a radar, exactly the same as a police radar gun, the same principle. It measures basically surface velocity. We combine those two velocity times area to give the flow. Why non-contact? That's a picture of a real flow sensor and a real sewer, and it's completely covered in fat. That's a nice way of saying what it's covered in, but basically it's fat. It means it's not working. So that's no good if you're going to try and measure real-time flows. That's another common thing, which we just call ragging. This is the flow into a fairly small treatment works with a wetted sensor located at the bottom of the channel. As you can see, although the sensor itself may not be covered up, the ragging will have the effect of dragging that cable away. So this is an installed example of our radar. It sits above the channel and it's measuring flow. This particular one outputs to a SCADA system, and this one is actually used to control in real time, basically a CSO, combined sewer overflow, which at the right flows, it will spill raw sewage into a river, which is perfectly okay. You're allowed to do that, but only in the right circumstances when the flows get to a certain point. So this meter must not fail, basically, because you can't have an accidental spill of raw sewage to a river. So what data do we get? Well, this is an example of real-time large sewer data. And what we've also got overlaid there is a rain gauge. So peak flow on this was over 5,000 litres per second. So it's 5 cubic meters a second. Obviously a very, very large trunk sewer. And we can see obviously the effects of rainfall. And very importantly, we can see the level and the velocity increase when we have some rainfall. I mentioned about needing a wide range. That's important because we can also use the same equipment to measure low flows. And here you can see we're measuring levels down to 2 millimeters, effectively a trickle, up to 73 millimeters in a very small pipe for a very small local sewer network. The importance of being able to measure these small flows is that you can pick up leakage and infiltration, even when you shouldn't have any flow. It's very useful. So finally, going on to power. Grid power, great, actually not that reliable in some circumstances. Solar power we've been using for our real-time flow monitors for many, many years. It is incredibly reliable. We've had systems running for 10 years with no power outages at all. It's very important the system's specified correctly and it's in this right geographic location. If you don't have the sun, you're not going to have the power. These particular systems, both of them, will provide 14 days of backup power with no sun. But that's not suitable for the more northern climates. So I'm now going to hand over to Knut, who's going to talk to you about off-grid power and how we do that. So.
So hello all together. I hope you can all see my screen now. I'm Knut from the company Altas IT in Germany, and we deal with the topic of off-grid power, and particularly with the Efoy Pro fuel cells that we have in the market for over 20 years now. So just to give you a brief background of our company, as I said, we are on the market for 20 years already, which is not really usual in this industry of fuel cells. It's just recently that this topic has become more public and more important to the public. 20 years ago, there wasn't any chance to get the attention we get these days for our fuel cells. So anyway, we've sold 50,000 fuel cells so far already since 2001, and with 100 million operating hours. So we are very experienced in what we do and how our fuel cells work. We are a global operating company. Our headquarters is in Munich, Germany, and we also have a subsidiary in Calgary in the Netherlands, in Almelo, and in Romania as well. So how did we become successful in such a small niche market? It's something to do with our focus on the customer expectations, and these expectations change as well over time. So we see now that there's a very strong focus on environmentally friendly energy solutions. And as Mark already said, we want to be 100% reliable in our energy supply as well. We want savings in personnel and logistic costs. We want long autonomy. We work also in the offshore industry. And we want the permanent connectivity and remote monitor all the data that we get from our devices. So this is why we just launched a few weeks ago the Efoy Pro Hybrid Power. It is a system consisting of the Efoy Pro fuel cell here to the left in the picture and the Efoy lithium battery. And this is a very strong combination for all off-grid power applications. To go a bit more into detail, what have we changed in comparison to the previous generation? The fuel cell has an extended lifetime and higher power output. We have more flexibility and a better connectivity. The battery is developed in Munich in our headquarters. We have our own battery management system, and we can charge the lithium battery at temperatures below -20 degrees or up to -20 degrees. And the technology itself is very interesting for high discharge currents as well. Just to say, we don't have to use the lithium technology. We can use the fuel cell as well with all other AGM or lead batteries as well. And in the combination of both devices is very powerful. We have an intelligent communication between those devices. So the fuel cell always knows the state of charge of the battery, and we only recharge whenever it's needed. And this makes the entire system very efficient. So how does the fuel cell work? We need air, we need the oxygen of the air, and we need the fuel cartridge with methanol. Then there is a chemical reaction in the fuel cell, in the heart of the fuel cell, which is the stack. And in the end, we get electric power, and we have waste heat, water vapor, and a bit of CO2 that goes out of the device. So it's environmentally friendly and very easy to install and to use. To have a look at the components, as I already mentioned, we have the Efoy lithium battery. For the operating options, we use the Efoy app. This is what we do via Bluetooth. We can also use the control panel, attach to the device and operate the device. And what we also can do is we can just connect the modem, and then we can get all the data in our Efoy cloud system. So we see the operating times, the voltage of the battery, all remotely from our personal computer back home. And we also have the Efoy Fuel Manager that allows us to connect more fuel cartridges from 2 up to 8, and this brings the entire system to a higher autonomy. Coming to our fuel cartridges, we have 3 different sizes, the M10, M28, and MT60. Usually we use the M28 in the industrial applications, but sometimes the M10 is enough, and the MT60 is only for like very long periods of autonomy. We also have a very high energy density in the methanol. So in this small cartridge down here in the M10, there are 11.1 kilowatt hours of electric energy inside that we transfer to electric energy via our fuel cell. Just to talk in battery capacity, this is about 925 ampere hours of a 12 volt battery. So, and they're very lightweight, it's only 8 kilograms. So these are our current devices that we have. We use the white devices for the leisure industry. It's for caravanning and sailing boats. They have a bit of a lower guaranteed lifetime, 3,000 hours. And then we have the Pro series with a bit of a different stack inside and other components. And this, for these devices, we guarantee up to 6,000 operating hours. And this is what we use in the industrial applications. And the power output starts from 40 watts to 125 watts at the most powerful device. Coming to the batteries, we have the Efoy 70 and the 105. This is the capacity from 70 ampere hours and then 105 ampere hours. And it comes all to a very light weight as well. So we only have 11.8 or 16.3 kilogram, which is way lighter than the actual AGM or lead batteries. So which fuel cell energy solution suits your application the best? Since here are all participants from the water companies, I will go a bit more into detail of these applications. So one thing that we use is the Efoy Pro cabinet. This is a cabinet where we can install the fuel cell, the battery devices, and as well the methanol, and then we can use the entire system to monitor the water flow. We also use the Efoy Pro Cube. We can combine it with solar power as well. We use the Efoy Pro trailer or the Efoy Pro energy case for mobile applications, and we also deal with customized solutions. So for water level measurement or water flow measurement, we have an energy demand of about 10 watts. And if we use the Efoy Pro 900 and 2 M10 methanol cartridges, this brings us to an autonomy time of 3 months without any other energy supply. So we only have to go there every 3 months and change our cartridges. And we can all remote monitor the system and see whenever new methanol is needed. So the Efoy Pro cabinet is one of our energy solutions. This is the case where you fit in the fuel cell and the methanol and all the other devices that you need. It's made of steel. We have a temperature range from -20 degrees to +50 degrees. We can fit 2 M10 cartridges in there and the Efoy Li 70, or we can use any other type of lead battery with about 60 ampere hours. So this is all from my side. I will give over again, give the microphone pretty much to Mark. And if you have any questions, please just feel free to write them in the chatter. We will come back to you later, or we will try answer them via email if we don't have time in the end. But probably there will be some time if you have questions for later on for us to answer them. So Mark, do you want to take over? I will just stop my slide here. Thank you.
Okay, so hopefully everybody can see my screen.
Right now we cannot.
Oh, sorry, hold on. There you go.
Yes, perfect.
Yes, excellent. Okay. So, thank you very much. That was very good. Something I would also add, the application example where we had 3 months running on the fuel cell is really a good illustration of what would happen really with winter here. Because if we combine that with a solar panel for the summer months where we have good light, it would basically mean that you would really only have to revisit a site potentially only once a year just to change the fuel cells, fuel cartridges. So why do we monitor in real time? There's lots of things. Really, it's to, one of the sayings that we use is, until you monitor, you're guessing. Well, that isn't entirely true, but to actually have real-time data in front of you, you really know what's going on. It's a bit of a truism. But basically, one of the uses for real-time monitoring is for billing. And this is done in a number of countries in Europe. That individual towns and villages can be billed for their sewage treatment or their sewage flows going out to an external, if you call it, treatment works. So we also can monitor, control and measure a sewage treatment network. I'll show one of the examples where an operator can actually control the flows before they enter his treatment works. And if necessary, hold back flows and using the sewer network for retention. We can also obviously see the effects of rainfall and snowmelt, and obviously leakage and infiltration. Leakage and infiltration studies can be short-term using portable battery-powered equipment as well. So let's so the first example I'm going to give, this is a network that's been running in northern Italy, a place called South Tyrol, for a number of years, really starting in 2001. It's basically a sewer network with lots of small towns and villages and one treatment works. And the flows are measured at different measuring stations. There's only over 51. They measure the flow remotely and send that data to a controller in a treatment works. This is the area. This is actually a screenshot of the controller's screen, and he can click on any of these measurement stations and see real time what's happening with the flows. You can also see it's a very mountainous region. But basically all these flows go down a network into a central sewage treatment works. There are a number of challenges with doing real-time flow measurement, particularly in mountain areas where you've got very small, maybe 150 millimeter, even in some cases 100 millimeter sewer channels, but they're very steep and very fast. So we have flow velocities of 4 meters a second, not unusual. Obviously, remote locations, and as we said, a lot of them off-grid. Now, in Italy, northern Italy, we don't have a problem with dark winters, so solar power is fine. But again, solar power may not always be the customer's preference. You may not want the solar panel as an obvious indication that there's some equipment there. And we've had this in some sites. They really want as low profile, literally as low profile as possible. But the requirement for the systems were they had to be very reliable, accurate, and also verifiable. So in other words, every year someone comes along and actually checks the flow readings independently to certify that they are satisfactory and that they can be used for billing purposes. So this is a typical installation. Again, relatively small solar panels, very, very small chamber, as you can see, drop down onto an existing sewer. You can see there the radar flow meter. The other cable to the left is the look down ultrasonic level sensor. So again, operating since 2001, used for real-time control. And again, the controller can select an individual measuring site. There are powered penstocks, control gates on each of these measuring sites, and he can set a maximum flow and leave the system to do a closed loop flow control. So the next one is quite an interesting application. This is in Brussels. This is called Flowbrew. Operating again since 2001. The data is sent via GPRS to DataNet. This data is publicly available. So I went onto the websites this morning and downloaded some real-time data, which I'm going to show you. So anyone, anywhere in the world can log into flowbrew.be and have a look at what is happening in Brussels with their sewer network and their rivers, rainfall collectors, etc. Quite interesting that they make all this publicly available. But this is what you get when you log in. Each of these little points is a measurement point, and it's either rainfall, wastewater. There are quality measurements as well. There are also surface water. So I had a look at one of the surface water drains. That's what you get when you click on any of those points. You get a representation of what the channel is. So in this case, it's a circular pipe. You can also see actual site pictures. And again, this is used for verification. Has the channel become blocked or overgrown compared to when it was first installed? But you can see there typical surface water flows. And there's a rain collection meter as well, which is here. And this is the data. So I downloaded this today. We're measuring level rainfall, which we can see there was a little bit of rainfall here and its influence on the flow. And this is up to today, 24th, and we can see debit, which is French for flow, peaking at 15 liters per second. So it's a nice example there with some really good data that anyone can access. So really, in summary, regarding flows, pretty much anything can be measured. It may not always be easy, but pretty much anything can be measured. Power can be available, as we said, either grid power or solar or fuel cell or combination of all three, in fact. You need reliable, maintenance-free systems if you're going to be doing real-time control. That's very important. Also, the ability to upgrade and improve. You may want to add things later on to systems, such as maybe redundant level sensors or quality measurement systems. And as a supplier, all I would say to potential customers is give us as much information as you have. It's always handy. And the other thing I always say is challenge your suppliers. We like difficult challenges. They make things interesting. So thank you very much. I think I'm going to hand you back now, and I'll just end on our final screen. So thank you very much, and ask any questions the Q&A. Okay, and do I stop sharing?
Thank you, Mark, and big thanks to Knut as well. So I hope so far it has been enlightening and a little bit educating for everyone. So the chat is open. If anybody has questions, you can do this in Estonian or in English. Just let us know what your questions are. If you don't have any questions for now, but you will remember something a little bit later, then our contacts are on the screen here, and we will make sure that we contact you in a very near future as well. So there is still a couple of minutes here before we will end this call.
Okay.
So any questions from your end?
And also participants can now unmute themselves if they want to ask orally their question.
Yeah, of course. So it looks like for now everything seems to be clear, but again, please feel free to contact us via email or phone numbers, and we will make sure that we will get in touch with you individually again after 1 or 2 days. So thanks for everybody for joining today. It was pretty quick and effective, half an hour, and we got it done. So we'll send you the recording and also slides in English and in Estonian as well. So I appreciate it again for everybody joining in today.